Today, I'm honored to introduce our distinguished guest speaker, Dr. Therese Grüter. So, Dr. Grüter holds a PhD in linguistics and language acquisition from McGill University with her distinguished work on object clitics and non-objects in the acquisition of French. Dr. Grüter is currently a professor and graduate chair in the Department of Second Language Studies at the University of Hawaii at Manoa. She also serves as an associate editor for the journal Language Learning. Dr. Grüter has the main area of research in sentence processing, developmental psycholinguistics, and childhood bilingualism. Her research investigates how language users of all kinds, adults and children, monolingual and bilingual, process and acquire structural aspects of language. She's particularly interested in how we integrate information from various linguistic and non-linguistic sources, how we do so as quickly and successfully as we typically do in everyday communication, and how this ability develops over time in various language learners. And today she will discuss capturing discourse level expectations using the visual world paradigm. Please join me in welcoming Dr. Grüter.
Thank you very much for the kind introduction, and thank you guys for having me. It's really nice to be part of this seminar. So let me share my slides, and at any point, I'm not very good at monitoring my chat in Zoom. So if you need to interrupt me, just unmute and shout. Now let's see. Can you see my screen? Okay, thank you for the nod. All right, so Aline had shared with me earlier when she invited me to the seminar and shared the syllabus, which looks great, by the way. I wish I could be there for some of the other talkers. That you guys hadn't talked, I was the first to talk about the visual world paradigm. And so I thought what we could do today, since this is a seminar and not just a talk, we could talk a little bit about the visual world paradigm, though I hear you've just done that. So I want to hear from you guys a little bit what you've already done. Because I think it's really important to understand what the basic assumptions, especially the linking assumptions underlying this paradigm are. And then I'd like to tell you a little bit about how we've made kind of creative use of this paradigm to try and capture discourse level expectations. Actually, first, we should talk about how other people have used the paradigm to try and investigate expectations or prediction in language processing, which has been a topic that a lot of people, and me in particular, have been interested. And then we could talk about the papers you have read. Does that seem reasonable? Good, good. So the one thing I want to start with, and it's been my pet peeve a little bit, but it's getting better, that eye tracking is not equal eye tracking. So the two main paradigms that have been used in psycholinguistics and cognitive science for several decades, it's only more recently that they've made their way to the field of second language acquisition, are eye tracking while reading and the visual world paradigm. And you guys have talked about eye tracking while reading, is that correct? You guys talked about eye tracking while reading? This kind of stuff?
Yes, we have. Yes, we have done that. Yeah. Can you hear us?
Yes, I can hear you.
Yeah. We'll pass, by the way, we'll just pass if, don't worry about the mic. We'll just pass it between us. So it should be interactive.
Okay, great. So whoever has the mic has to answer, right?
That's right. I'm passing it on to Kio now.
Excellent. So in the eye tracking while reading paradigm, which I won't talk about any further, participants read sentences on the screen and their eye gaze is measured. And just really quickly, what kind of dependent measures do researchers look at in eye tracking while reading?
So maybe researchers focus on the early measure, several early measures and late measures like first pass reading time and rereading time and total reading time, that kind of various different types of dependent measures.
Right, that's exactly right. Thank you. So in this paradigm, if those measures are longer, let's say if your total reading time in a particular region is longer, what is that taken to mean? What do researchers infer from that about language processing?
So you said that what can we infer if the reading time is longer? So we can infer that the processing is going slower. So maybe there's something that the participant didn't understand in the word before or in the word that they're reading or something like that.
Right, exactly right. So it indicates difficulty, right? Processing trouble of some kind, right? Right. So bear that in mind. That's the linking assumption in eye tracking while reading between eye gaze and linguistic processing. Now, the other big measure, the big paradigm that eye tracking tools have been used for is the visual world paradigm. In this paradigm, participants listen to sentences. There's typically no written language involved. You just listen to audio or sometimes just individual words while looking at an array of pictures on the screen. Okay? And we'll get to what dependent measures are taken in this paradigm, or maybe you guys already talked about this, in which case this will be repetition. But these are two completely different paradigms. And here's just a bit of history about the original visual world paradigm in case you wondered where does that name come from? What's the world? Originally, this was a very low-tech tool. Right? This didn't involve an expensive eye tracker. This is from the work from John Truswell's lab, where there was a little stage with actual objects placed there, and that black thing in the middle, I don't know if you can see my cursor, that's where the camera was hidden, right? And sound would play from regular old loudspeakers, and they would film the participants with a video camera during the experiment, and then code video frame by video frame, which is about 33 milliseconds for a typical video camera, hand code where they were looking. Right? And typically in this paradigm, participants were asked to pick things up. I think this is the famous study where they would say, tickle the frog with the feather. And there's a frog who already holds a feather, I think, this one. And an instrument. So there's how do you interpret tickle the frog with the feather, the frog who already has the feather, or take the feather to tickle the frog. That's the original visual world paradigm used with adults in the Truswell lab later on as well with children. There's a parallel research stream that happened mostly independently in infancy labs, developmental psychologists looking at early language development in infants and toddlers, with whom you cannot do most tasks that we're used to doing with second language learners. They're not going to give you grammaticality judgments. They're also not going to pick pictures for you and point. So eye tracking methods, variably known as the intermodal preferential looking paradigm or the looking while listening paradigm, are a great way to get at comprehension in very, very young learners, where you typically have two monitors or just two pictures projected on a wall, sound comes out, and again, a video camera hidden somewhere where you code frame by frame afterwards where the child is looking. This is very, very labor intensive. Again, doesn't involve an expensive eye tracker. Actually, I should have, give me a second. I should have shared this with you with video, right? Share sound, optimize video. Let's try this again. Oops. You are not sharing. Nope. Let me try this again. You don't want the whole thing. There you go. Do you see my screen again?
Yeah, we can see it.
Yeah. All right. So basically the way this would look is something like, I don't know if this video will work.
Look, it's Dora and Diego. They want to play with you. Let's look at some pictures. Where's the car? Pretty neat, huh? Look, Dora is touching the shoe. See the cookie? Check that out.
And it keeps going like this. Were you able to hear this?
Yeah, we could hear it.
Okay. That's essentially the visual world paradigm with children. And in case you're worried about parental consent, don't worry, that's me as the parent in the background, and that was my son a while ago, as you can tell from the timestamp on this. I was a postdoc in the Fernald lab, and I spent many painful hours hand coding eye tracking data like this. But I just want you to know this is eye tracking as well. It's not just, you know, a sexy, expensive tool. It really is, where do people look when they hear spoken words. Any questions so far? We good?
I think we're good over here. Thank you.
All right. So visual world paradigm, and keep in mind the question, what does looking at a picture longer, or what does eye gaze to a picture tell us about linguistic processing in this paradigm? I'm going to keep this and keep your wheels turning for now. Eye tracking while reading and the visual world paradigm in psycholinguistics and cognitive science have always been known and recognized as very different methods that happen to use the same machine or the same general tools. It's typically done in psycholinguistics and cognitive science by different people and different labs. So there are eye tracking while reading labs and visual world labs. And it's typically specified which method is meant. So these references are from a handbook of psycholinguistics. One is about eye movements and spoken language comprehension from experts on the visual world paradigm. And one is from eye movement control in reading from some of the key leaders in eye tracking while reading. So these are known as very different methods. In second language acquisition and applied linguistics, when our field started discovering eye tracking as a tool, and I would say around 2010, they were initially, to my great frustration, often treated together. There were these papers about using eye tracking, and that really doesn't mean very much. And it's very difficult when you conflate the tools for eye tracking while reading and the visual world paradigm. It's very difficult, I find, to treat them. You can't treat them as one method. Thankfully, this has changed with this wonderful book that Aline wrote, where there are separate chapters dedicated to text-based eye tracking or eye tracking while reading and the visual world paradigm. So I think our field is starting to understand that these are separate methods as well. So just as a please, when you say, I'm going to do an eye tracking study in the future, please say, I'm going to use eye tracking while reading or text-based eye tracking, or I'm going to use the visual world paradigm. Because the linking hypotheses that underlie these paradigms are very, very different. We've already talked about the one for eye tracking while reading, but what is the linking assumption between eye gaze and linguistic processing in the visual world paradigm? So let's think about this for a minute. If you have images on the screen and hear a sentence, what dependent measures do researchers take? I don't know if you've already talked about this, if this is what you did in the past half hour. What can we get from eye gaze measures in the visual world paradigm about linguistic processing? Any thoughts?
I'm going to give it a try, but this could be wrong. So they're hearing something in the visual world paradigm, so you can see what they're predicting on based on what they've already heard.
Do you have an example in mind?
Yeah, so if you want to, like the one that you showed earlier, like the pirate chases the ship. So based on the noun that they hear, the pirate, which of the objects do you think it would be most likely or least likely to be interacting with, following that based on the noun and the verb that comes up, right? So kind of those like links between different nouns and verbs with each other.
Mm-hmm. You're already one step ahead to look at how this paradigm can be used to measure not about what we're hearing right now or what we're processing right now, but what might be coming up in the future. You're very much on the right track. This is actually not what the visual world paradigm was invented for, right? But you are definitely very much on the right track. But then what kind of dependent measure would you take? Are we interested in whether you look longer at a picture or not as long at a picture? I compare analogous to like how we would look at text longer or less long in the eye tracking while reading paradigm. What about eye gaze matters here?
So it's maybe proportion of looks to the pictures up on the screen.
Mm-hmm. So whether you look to one picture more than the other, yeah?
Mm-hmm.
Very much on the right track. But then what does looking at the picture indicate? Processing difficulty? Or what does looking at a picture, what's the linking hypothesis to cognitive processing?
So if you look at this particular picture proportion, if there's a longer proportion or larger proportion on particular picture, that means you've predicted that the pictures, I guess there's like referential processing going on when you look at that picture.
Yes. Yes. What do you mean by referential processing? You're exactly right. Can you elaborate on that?
So, can you tell me the question again? I missed it.
What do you mean by referential processing? I said you're exactly right, but can you just elaborate what you mean by that?
So based on what you like, when you hear some type of a sentence or read some type of a sentence, you basically have a sense that something's gonna come up. And so you predict what's gonna come up, and that's what I'm trying to say when I say referential processing.
Mm-hmm. You're right, but you're again, I guess prediction is so ubiquitous now in everybody's minds. I want to take you a step back to, you're exactly right, but I want to make sure you understand the basic linking assumption here. This is from one of the first in a classic study using a visual world paradigm to study spoken word recognition with adult native speakers of English. This is Alopin et al. 1998. This is what computer screens, visual scenes looked like in the 1990s, which you guys probably don't remember. So they're pretty ugly. These words were introduced at the beginning. This is a beaker, this is a speaker, this is a beetle, and this is a carriage. I think this work was done in the UK. And they were simply interested in how quickly people access words in their mental lexicon and what kind of competition is going on during lexical access. So they simply heard, I believe they heard individual words, beaker. They heard beaker. And what they measured, I don't know how familiar you are with these graphs yet. On the x-axis, you have time from the onset of the word. So this would be the onset of beaker. This is about where beaker would end. And this is fixation probability, like one of you has said, plotting the probability with which participants would look to each of these 4 areas of interest. Okay? So when they heard beaker, they would, of course, eventually, pretty quickly, by the end of the second, always look at beaker because these are adult native speakers. What they were interested in is what other words get activated and on what time scale. So beetle, you see, looks to beetle are higher than looks to speaker and carriage. Why is that? The speaker didn't say beetle. Why are people more likely to look at beetle than at speaker or carriage, do you think? Who's stuck with the microphone?
Because the pronunciation of the words, first part of the pronunciation of the words are similar.
Right. They're so-called cohort competitors. They start with the same syllable, B, right? So they wanted to see how quickly we access words, meanings in our mental lexicon when we hear sound. You know, the traditional definition of a word, a pairing, an arbitrary pairing between sound and meaning. How quickly do we do this? We could wait until the end of the word and then search for the word in our mental lexicon. Well, this isn't news now, but it certainly was news in the 1990s that we don't do that. We incrementally integrate information sound by sound to narrow down our understanding of what the speaker is talking about, right? This isn't prediction necessarily. This is incremental integration of each bit of sound, right? So the linking hypothesis here is that fixation on an image tells us about the speaker's activation of the referent of a word in the mental lexicon. That's very basic, but I think it's important that we're aware of this. Here, it's as the word is being mentioned. It isn't prediction, really. Okay? But then others have used this paradigm to look at prediction, and we'll get to that. Any questions about this basic assumption underlying the visual world paradigm? Are we good?
Oh yeah, we're good.
Okay. Your image on my end is very small, so you guys have to speak. I can't really see you. Right. Okay, so this is the basics about the visual world paradigm. And then how has this been used to capture expectations or prediction? And it sounds like you guys already know a whole lot about prediction. This is something that has entered the psycholinguistics world in the past couple of decades. And it's the idea that not only are we very fast at integrating everything we hear, like each sound, the moment we hear it before the word is even over, we integrate that to make meaning of the world around us and what people are saying. In addition to that, we also use all the information we have at any given moment in time to create expectations, proactive expectations about what the speaker is likely to say next, or what is likely to happen next in a broader sense. That's the idea of expectation. And to illustrate with a seminal study, with a simplified version of a seminal study, how this might happen in language processing, let's look at this visual array and assume you hear the following sentence, which I will read to you. The boy will eat. And I'm going to stop here and ask you, which picture are you looking at? And my guess is you're looking at the cake, but I haven't actually said cake. Why were you looking at cake? Well, because you already had enough information from the linguistic signal, the verb that you know takes an object and typically takes an edible object, and your world knowledge, namely that people are more likely to eat cakes than trains, to create a very strong expectation that I'm probably going to say cake. So you already looked at cake before it was mentioned. Now, if I had said the boy will move, it could have gone either way. You wouldn't have had enough information to create a strong expectation. That's the logic underlying this study that some of you might know by Altman and Kamide, which used visual scenes like this and sentences like the boy will eat the cake, will move the cake. And here you have a similar plot, time from verb onset here, so eat or move. This is about where cake started. This is on the x-axis, and probability of looking at the object that is eventually named cake. So this line that I've colored orange is when the verb is informative, allows you to create an expectation. This is when the verb is not informative. And what is important is that before the onset of the noun, before they hear cake, there's already a difference in the proportion of looking to the target. That's the classic measure of prediction using the visual world paradigm. Whoops. That's all clear? Good on that?
Yes.
Yeah?
Yes, I think so. Yeah, right. Yeah. Yeah, we're okay.
You're okay? All right, feel free to interrupt with questions. Now it's a little awkward with the way you guys have to pass around the microphone. So it's from studies like this and many, many others that we know that speakers and listeners predict, anticipate, expect, think ahead. I'm going to use all these terms interchangeably here during real-time language use. Now, the vast majority of this evidence comes from speakers and listeners like this. Young, healthy, well-educated, Western, typically monolingual native speakers, right? We know that they anticipate, they predict. There's now also quite a lot of evidence from this kind of speaker and listeners, young children, again, the vast majority with monolingual children, shows that even at the age of 2 and 3, they already engage in predictive processing. So this isn't some kind of a trick that only really smart people develop over the course of their life. Prediction seems to be part and parcel of how we process language, at least a native language. That's what we know so far. There's also some really interesting research with speakers and listeners like this, elderly speakers. Research has shown that they might engage in prediction differently from younger native speakers. I won't go into details, but if you're curious, you can find that literature. What I have been interested in for quite a while now was speakers and listeners like this, people processing a later learned or non-dominant language. And when I first started getting interested in this, there really wasn't a whole lot of work on this. And I'll tell you a little bit more which study was it that got me hooked on this topic. So to what extent do second language users predict during language processing? What we know so far is that L2 speakers use lexical semantic information like the eat cake, move cake story to predict. Effects can be smaller. Sometimes they show up a little bit later in the time course when you compare with monolingual native speakers, but that's not always the case. L2 proficiency may matter, and you think it would, but it actually remarkably often does not matter. And that's a point I will return to. But certainly there's plenty of evidence showing that L2 users can use lexical semantic information to create proactive expectations in real time. It is still less clear to what extent L2 speakers can use grammatical information to predict. And I should point out the vast majority of this research has looked at grammatical gender in mostly Romance and Germanic languages. The nice exception is the work by Mitsugi and McWhinney that has looked at case marking in L2 Japanese. So what does it mean to use grammatical information to predict? This is work that, again, some of you might be familiar with. This is in Spanish. So if you look at this visual array and you hear a sentence in Spanish, find the feminine marked. What picture are you looking at? And I've already given it away. I don't know if we have any Spanish speakers. And I should emphasize this was done for Mexican Spanish speakers, in case we have Spanish speakers. They might already look at the ball. Does anybody know why? I just said find the. How can you know that it's the ball?
So Brittany said it's because of the feminine.
It's because of the feminine, because as it happens, at least in this variety of Spanish, shoe is masculine, ball is feminine. This is marked on the determiner. So just like eat was informative about cake, this feminine determiner was informative, given this visual scene, about the noun that will be named. So you could already predict that I would talk about the ball. Right? Make sense?
Yes.
Now, if this had been the visual scene, cookie happens to be feminine as well, you would have had to wait, right, until I actually said the noun. So again, the logic is comparing these two conditions. Are you faster to look at ball when paired with shoe than when paired with cookie? If so, if you're faster to look at the ball, that means you're using the gender marking on the determiner predictively to create an expectation about the noun. That's the logic. That was the logic underlying the seminal study by Lou Williams and Fernald, in which they did this with native speakers of Spanish, both adults and children. And these were very young children. These were 2 and mostly 3-year-olds. And as you can see, both groups looked at the target earlier in the different gender condition, that's the shoe and the ball, than in the same gender condition. The children were much slower and overall much less accurate, but they got at least as much of an advantage from the gender marking. So even at this early age, when for the most often they don't even produce determiners, they're already engaging in this kind of predictive processing. That's really quite impressive. Now, in a follow-up study, Lou Williams and Fernald 2010, they ran basically the same experiment with L2 adults. And these were native English speakers. These were college students at Stanford in Spanish classes, I think 2nd and 3rd year Spanish classes. And the L1 adult and the L1 children data is the same as in the previous slide, just plotted a little differently. But here you can see the data from the L2 adults, and my color coding looks really ugly because the lines are right on top of each other. And what you can see is that the adults are much faster than the children, and they're much more accurate than the children, but they're not getting an advantage from the gender marking on the determiner. So it looks like they are not using gender marking to predict an upcoming noun. Okay? And that's really what got me hooked personally on this topic. I had just joined the Fernald lab as a postdoc when they were finalizing that study and presenting it. And I was both fascinated and horrified by this work. Fascinated because this whole new tool to look at prediction in processing through eye tracking, the visual ball paradigm, I thought what a great way to further our understanding of L2 processing. Horrified by the conclusion. The conclusion was that, well, it looks like this is something that native speaking children can do, but if you can't do it in a non-native language. And I said, well, if you want to conclude that, if you really want to investigate that, you need to go find the most highly proficient sequential second language learners that you can find. And they said, fine, you do it, right? And so after we knew that young and adult native speakers can't do it, and 2nd and 3rd year Spanish class students at Stanford don't do it, we basically ran the same study again with very, very highly proficient late second language learners of Spanish. Some of these were court certified interpreters. None of them had been exposed to Spanish in childhood, but they were very, very proficient. But they looked, I'm not even showing you the graph, they looked exactly like the L2 adults here. And that really had me hooked. I mean, thinking, well, maybe that is something specific about processing a language, a non-native language, that maybe we just don't have the bandwidth to engage in prediction because we're so busy with lexical access, which is more complicated in a bilingual mental lexicon. Maybe we're too busy with syntactic integration in a syntax that is not as automatized as our native syntax. Maybe we just don't have the bandwidth to engage in prediction. And that was really what underlied the hypothesis that my colleagues and I came up with a couple of years later. We called the rate hypothesis, that L2 speakers have reduced ability to generate expectations. And I really want to emphasize that we just put that out there basically to tell people, hey, let's look at prediction in L2 processing. And I want to give credit where credit is due, because when we proposed this, we weren't aware actually that Edith Kahn had already started working on this in a book chapter published in 2010, and then in this beautiful review paper that she wrote in 2014, pretty much putting out the same hypothesis that something's up with prediction in L2 processing. So I want to give credit to Edith for being the first to talk about prediction in L2 processing, as far as I know. And given our common interests, we then joined forces, and we're very proud of this book that we edited. It came out last year and has some really great chapters about, I think, the cutting edge work on prediction in second language processing and learning. And I understand that you have Holger Hopp talking to you next week. So hopefully you'll hear more about the learning part from him when he talks to you next week. So far by now, we know quite a bit about the extent to which second language learners predict using lexical, semantic, and grammatical information, but there's much less is still known about expectations at a discourse level. More work has been coming out, but when we first started thinking about this, there really was very, very little beyond the sentence level. So this was part of a bigger project, several projects in my lab over the past a decade or so, and I'm not going to be able to talk about all of them today. I just want to give a shout out to my former PhD student, Hyunwoo Kim, who's now teaching at Yonsei University in South Korea. He looked at discourse processing in implicit causality using the visual world paradigm, if you're interested in that. The project that I'm going to talk about today was a joint project with my colleagues Hannah Rodi in Edinburgh and Amy Schaefer here in Hawaii, where we looked at specifically the role of grammatical aspect in reference processing. I'm going to tell you, I know you read the papers, but I'm going to walk you through this a little bit more. You read these two papers, just study 2 here, but I'm going to tell you a little bit about study 1 before we get there. Study 1 is a very simple, old-fashioned pen and paper written story continuation task. And in part, I want to talk about this because I feel there's still a lot of insight to be gained about processing from offline tasks. For some things, we need online measures like eye tracking in the visual world paradigm, but we often need, prior to that, offline measures to give us a good sense of what it is that we're looking for in an eye tracking study. So let me tell you a little bit about discourse level expectations and reference resolution more generally. And there's a much older literature on discourse processing that has relied almost exclusively on offline measures. And the key focus of this literature, I think, is summarized beautifully and very concisely by Did I do something?
Yeah. Yeah. I think we are good. Our Wi-Fi was unstable a little bit.
Oh, it might have also been my end. I hope I didn't press the wrong button.
No. I think that's our end. On our end.
Okay. Should I just pick up where I left off?
Yes, that's fine. Right now our Wi-Fi is stable. We hope. So I guess we'll just keep going through it. Sorry for the interruption.
Okay, no worries. But you can hear me now and you can see my screen again?
Yes, we can hear and see you fine.
All right. Okay, I'll just keep going then. All right. So the idea with this situation model is that when we know that these mental models that we create while we process language and discourse, and we incrementally update while we process discourse, they contribute to our expectations about how a discourse will continue, and more specifically about who will be mentioned next. So when you hear a sentence like, when he gave Nancy some chocolates, the situation model that you create might look something like this. Now, if you're asked to continue this discourse, starting with the pronoun she, I'm sure you can easily come up with continuations in which she refers to Winnie and others in which she refers to Nancy. But as it is, there's a long literature, big literature on this. There are a number of well-known cues that drive our biases when it comes to the interpretation of ambiguous pronouns, such as this one. For example, we know that pronouns like to take antecedents that are subjects. We know that they like to take antecedents that have a parallel grammatical role, here also subject. Antecedents that were first mentioned in the previous sentence, and so on. In this particular case, most of these well-known sentence-level heuristics should drive us towards a subject interpretation, that is one where she refers to Winnie. So you should have a bias to continue this discourse saying more about Winnie. However, in the case of sentences just like this one, namely describing transfer of possession events in the past tense, previous research going back to work by Stevenson and colleagues in the early 90s, and also the early work of Jennifer Arnold, has found that when people are asked to continue discourse fragments like this, they refer back to the goal, in this case Nancy, in a remarkably large number of cases. And Stevenson and colleagues proposed a sort of a post hoc explanation that this bias may be driven by event structure. That is, a bias to focus on the end state of an event. In the case of transfer of possession events, the end state is when the goal has the theme. Here, Nancy has the chocolates. And this puts the focus on Nancy and potentially creates an expectation to hear more about Nancy, the person who now has the chocolate. What's she going to do with them? Hannah Rodi and her colleagues put this explanation to the test and said, well, if this is true, if this is really about the end state, then shifting the focus away from the end state should reduce the proportion of goal continuations, so fewer references to Nancy. How do you shift focus away from the end state? Well, by making the event incomplete. How do you make an event incomplete? In a language like English, we have a linguistic means for that, namely we change perfective aspect to imperfective. So now if you have a sentence like, when he was giving Nancy some chocolates, your situation model might look subtly different, might look more like this. Okay? Question is, if you're now asked to continue this discourse, starting with the pronoun she, will your preference shift to talk about Winnie versus Nancy? Rodi and colleagues' hypothesis was, yes, it would. With perfective aspect, when he gave Nancy some chocolates, you're more likely to write about Nancy. And if you change it to imperfective, you should be less likely to write about Nancy because now it's no longer about the end state. They put this hypothesis to the test in a simple written offline story continuation task, and they found exactly what they predicted. Namely, generally more reference to the source, the subject, the source of the event, but this difference was much bigger with imperfective. Oops. Fewer reference to the goal after imperfective than after perfective. Okay. This effect has since been replicated multiple times with native speakers of English. It has also been partially replicated with adult native speakers of Japanese, which is a language that also marks aspect grammatically. And we replicated it in Korean with adult native speakers of Korean, another language that marks aspect grammatically. So just to give you the general logic here, the idea is that verbal aspect influences the situation model that we create incrementally as we process discourse. And this situation model in turn influences the expectations, our expectations about who will be mentioned next in the discourse, our proactive discourse level expectations. That's the logic. So our first step was to say, well, can we replicate this effect with Japanese and Korean speaking L2 learners of English? No one has looked at this in L2. If there's really an issue with creating expectations, if there's rage in L2, then they should have a harder time. We should not see a difference between the perfective and the imperfective condition. We specifically chose to look at Japanese and Korean learners of English because we know they do this in their L1 from these previous studies that I've mentioned. So this isn't something they have to discover or learn in English. If they don't do this in English, it really shows us something about L2 processing processing specifically. So this study one, which I'm going to tell you about just really quickly, we basically did a Rode et al. Study just with non-native speakers. We had to make adjustments to the vocabulary we used and so on. We're on a bunch of adult native speakers of English and a bunch of Japanese and Korean learners of English. I won't separate the two learner groups because effectively the results were identical. So in addition to the main task, we took 3 independent measures of proficiency because we wanted to see to what extent any potential effects might be modulated by proficiency. And importantly, we conducted an independent task. We used a truth value judgment task for that, to check that they actually know the difference between perfective and imperfective, to check that they actually know she gave him a cookie versus she was giving him a cookie, that one is associated with a completed event and the other with an incomplete event. And I'm happy to tell you more about this task. I won't go into detail for now. I'll just ask you to take my word for it. They understand the difference. This isn't an issue of linguistic knowledge. So now we wanted to know, are they using this in referential processing in their interpretation of ambiguous pronouns? And this is methods and results in one slide, because I know you want to hear about the eye tracking studies. So essentially what they had to do, they got sentences like this: Emily brought or was bringing a drink to Melissa. She, and then they had to continue this discourse. In half of the items, they got an ambiguous pronoun. In the other half, they just got a blank line, so they could write whatever they wanted, in which case they actually often started with a name. So they would start with Melissa or Emily. We then coded these continuations to see if that subject of the continuation referred to Emily, the source, or to Melissa, the goal. And in particular, if this relative reference choice changed depending on aspect. So what you can see here, the first 2 bars are the native speakers, the second 2 bars, the non-native speakers. Pro means when they saw the pronoun, free means when they just had the blank line. And the 2 bars, the 2 colors indicate the 2 different aspect conditions. With the native speakers, once again, one more study that replicates the basic effect, namely that there are more source and thus fewer goal continuations following imperfective than perfective. That's exactly the same effect as Rode et al. Had found originally. This was the case both with a pronoun and in the free condition. You can see overall in that when they just get a blank line, there's fewer source continuations overall. These bars are much lower than these bars. And that's because they typically choose the name to start the continuation in this condition. And we know that fuller referential expressions, such as names versus pronouns, are more likely to go to a non-subject. So this is also replicating previous effects. A pronoun is more likely to go to the subject, here source, and a full name, a fuller referential expression is more likely to go to a non-subject. Looking at the non-native speakers, we also see this big difference between the pronoun and the free condition. But remarkably, we do not see a difference by aspect. This looks like it's numerically a little bit higher, but the effect of aspect was not significant in the L2 group, and there was a significant interaction between aspect and group. So we conclude that both L1 and L2 speakers use prompt type, by that I mean pronoun versus free continuation. So the L2 learners weren't just insensitive and writing anything. They were very sensitive to the form of the referential expression, but they did not show an effect of aspect on their reference choices. So I'm calling this a reduced effect of aspect here because there was actually some other part of the data that I won't talk about here that suggests they were paying attention to aspect, but they were not using it to inform their reference expectations. So what we concluded from this study is that, well, no, we could not replicate this with Japanese and Korean learners of English. And this is, in fact, consistent with the rage hypothesis that they may have reduced ability to generate expectations. They might just process incrementally, but not predictively. I do want to mention that we found absolutely no modulation by proficiency. That was unexpected, and it's unexpected for the rage hypothesis, because if not engaging in prediction is some kind of a bandwidth problem or a bottleneck problem, as Holger Hopp would say, then it should get better with increasing proficiency, with increased automatization, increased better lexical access, but it wasn't happening. And we thought, well, I mean, it's a null effect, fine. Our measures of proficiency did intercorrelate, so, but maybe we just didn't capture it in this study, but keep this in mind. The other concern with this, that was mainly brought to us from psycholinguists, said, well, are these co-reference effects in written offline story continuations really effects of prediction? Can you talk about prediction when you're not doing an online task? And I do think we can talk about expectations. The discourse processing literature has done so very fruitfully for several decades. But it is an interesting question whether aspect might affect reference even before a referential expression is encountered, even before a pronoun or that blank line that prompts you to do something, even before that. Are people's biases shifting in their expectation of whether one person versus the other would be mentioned next? So for that, we decided, let's see if we can use the visual world paradigm creatively. And by creatively, I mean, what I've shown you before is that typically people would use the visual world paradigm in like this grammatical gender study where there's a very clear acoustic cue, namely the gender mark determiner, that is your prediction signal, your prediction cue that can be potentially informative, and link that to looks to a picture. Now here we don't have a clear cue that will prompt you, aha, now you can create an expectation. It is the linking hypothesis is much more tenuous because it's the situation model, and we don't know quite when in time this situation model is created. So bear this in mind, this is not a typical use of the visual world paradigm, but I'll leave it to you and we can discuss afterwards how convinced you are that it's actually useful. And I think there's reasons to be skeptical for sure. So let me tell you what we did in this study. But before I continue, are there any questions so far about what I've said about aspect and study one?
No questions so far, Therese.
Okay, all right. Thank
Onward.
you. So what we try to do here is for each trial, each item in this experiment consisted of what we called a mini discourse. And it really is mini. It consists of 2 sentences, like what you have here. Donald brought or was bringing Melissa a fancy drink. He or she obviously liked hosting parties. And the visual scene consisted of 3 areas of interest: the source, the goal, and the theme. Donald, Melissa, and the fancy drink. Now you notice that compared to the, unlike in study 1, the 2 participants have different gender, right? So there's a male and a female. There's no ambiguous pronouns here. By the time you get to the continuation sentence, reference is disambiguated. And we're following this design used in a, this is an ERP study by Ferretti et al., who were specifically interested in, do you get any kind of a P600 or any measure of disruption when the pronoun here does not agree with the expectation you've created based on aspect. We tried to follow their design, and we were also interested in looking, is anything happening in this pronoun area? But I'm not going to talk about this. In this study, essentially, there was nothing that we could see in the eye tracking record. What we were mostly interested in, and that's what I'm going to focus on here, is does this manipulation, perfective versus imperfective aspect in the first sentence, does that influence where people are looking in the pause between sentence 1 and sentence 2? So after they've heard this, and before this sentence started, we inserted a slightly longer than natural pause because we wanted to see if anything happens, to see if they are proactively looking at either Donald or Melissa, and particularly if their relative looks to these 2 discourse participants differed depending on aspect in the first sentence. Does that make sense so far? Now try and illustrate.
A lot of nods.
I see, yeah, I see small nods as well. Great, thank you for the feedback. So I hope this plays here. And I want you to know what exactly these stimuli look like. They're also publicly available, but I want you to see that how the pause was actually quite long. So this would be an example of one trial. I hope you'll be able to hear this.
Donald brought Melissa a fancy drink. She obviously liked hosting parties. Who liked hosting parties?
So that's what you would have done if you had, let me just pull this back again. if you had participated in this experiment. This would have been one trial. And so first you would have seen this, the visual scene, so-called preview for 2 seconds, then we call the context sentence, then a 2.5-second pause. And this is our critical region of interest. And then the continuation sentence, which disambiguated, sometimes one way, sometimes the other. And then another pause. And then during the pause, you saw the visual display changed. It changed, the pictures actually disappeared. And at this point, we don't really care anymore what the participant does. We're just trying to keep them on their toes. We try to disguise the purpose of the experiment as sort of a memory task, where then they would hear who liked hosting parties, and they had to click on the box corresponding to where the answer used to be, right? And we're also not really interested where they clicked. What we're interested in is here during the silent period where I still see the visual scene, their relative looks to Donald versus Melissa. And we're taking that, our linking assumption here is that if they're activating these reference, Donald or Melissa, to be topics of the continuing discourse, then they should be looking at them. That's the assumption, right? And that's maybe an assumption that one could question, but let's see what we found. So we ran this study, and I know I gave you both references here. We ran a study both with native English speakers and non-native speakers. We ran it first with English speakers because no one has used the visual world paradigm for this kind of thing, to look at proactive expectations in discourse. So we really wanted to talk to the discourse processing folks who don't care about SLA. That's why we published this short report in Cognition first. And at the time, we were still busy collecting data from the non-native speakers. But as you would have seen, this is essentially, it's the same experiment. In the applied psycholinguistics paper, we just compare with the non-native speakers. We included non-native speakers of a variety of L1 backgrounds because as a result of study one, we saw that having this property in your L1 doesn't really help you. Right? Doesn't really make a difference. So we felt for broader generalizability, we're just going to include everybody, all non-native speakers of English. That also allowed us to get a wider range of proficiencies because it's difficult to get Japanese and Korean learners at the highest level of proficiency, at least here in Hawaii. Again, we included 3 measures of proficiency, and again, we included that independent task to make sure that they actually understand, have the relevant linguistic knowledge. And again, I'm going to ask you to take my word that they get it. Question is, are they using aspect to create proactive expectations while listening to these mini discourses? All right. And here, what I'm going to show you, this isn't yet showing you the answer to our research question. What I'm showing you is just an overall plotting of looks to the 3 AOIs over the course of this long trial, collapsing over both aspect conditions and both referent conditions, whether it's he or she. Just to sort of give you a sanity check here. So here you have, we have a different example sentence. I think that's the one from the applied psycholinguistics paper. Patrick gave or was giving Emma a bottle of nice wine. So what you can see here, black is the source. So when they hear Patrick, they look to Patrick. Was giving Emma, this is the goal. They look at the goal when the goal is mentioned. A bottle of nice wine looks to the theme, right? So this is exactly what we would expect from incremental processing, the kind of paradigm that the visual world paradigm is typically used for. People look at what is being named. And something that's quite striking is see how similar the native speakers and the non-native speakers are, the time course. There's no indication that the non-native speakers are slower in any way to look at what is being named. They're processing the sentence just as fast as the non-native speakers, as the native speakers. So these graphs look identical up to the end of the sentence. And then we're interested in what happens in this pause, right? And I know in that paper we talk about 2 critical windows. Whoops. The other one also during the continuation. I'm not going to focus on that, but feel free to ask about it. Our main interest is the silence window, the intersentential pause. And let's look at what happens here, looking at the native speakers first. So at the beginning, they're still mostly looking at the theme. So here, the bottle of nice wine, because it was the most recently mentioned, right? That makes sense. These looks start tampering off over the first half of the silence period. At the same time, looks to the 2 human participants start going up. But about halfway through the pause, it looks like people prefer to look at the goal over the source generally, right? So this gray line is higher than the solid black line. That's, we don't know why, and things were counterbalanced. It's not that somehow Emma was more interesting than Patrick. There seems to be something about looking at the goal more than the source. And interestingly, this is exactly the same in the non-native speakers on exactly the same time scale. The only difference is that they like their looks to the theme temper of faster. We don't quite know why, but there's this general goal bias, which is consistent actually with this old offline discourse processing literature showing that in transfer of possession events, people generally have a preference to look at the goal. Now, the big question is whether this is modulated by aspect, which I haven't shown you yet. But are there any questions about this graph so far, what I'm showing you here?
No, everything's clear so far.
Everything clear so far. All right. So on the next graph, what I'm showing you, I'm not showing you looks to the theme, to the wine or the cocktail anymore, just looks to the source and the goal, and split up by aspect. And I wish I had better colors here, but I'm going to color code this on the graph for the native speakers at the top. So this is when they heard perfective, gave a bottle of nice wine. The gray line here at the top is looks to goal, and the black line is looks to source still. So what we see is in the perfective condition, this is where this goal bias is coming from. In the perfective condition, there's a clear bias to look at the end state, at the goal of the event. Now, if we look at the imperfective, this goes away. This is perfectly consistent with the offline results we've seen before, that the goal bias is driven by perfective aspect, and changing the aspect modulates that bias. It essentially goes away. So this is a result that we were super excited about, that we actually see this in adult native speakers. We see this as that aspect affects reference, expectations about reference before a referential expression is encountered, before the second sentence even starts. So this is evidence that people are proactively thinking about who will be mentioned next. And that was, I found exciting. The visual world paradigm is able to capture this in this potentially slightly unnatural discourse with a long pause. I will add that. I'm happy to hear your comments about it. Now, for the L2 learners, I haven't even bothered color coding because these lines are basically all on top of each other. And I'm not even showing you error bars. If I did, it would be one big shady mess. For the L2 speakers, we see no evidence that aspect affects reference expectations in real time. Although we saw that same overall goal bias, but it is not modulated by aspect. It was also, none of this was modulated by proficiency. And believe me, we tried. We really wanted it to be modulated by proficiency. Our proficiency measures were very decently intercorrelated with each other. So we really believe that we captured relevant variability, but it just didn't. If anything, the effect was, the trend was in the opposite direction. The less proficient learners looked more like the native speakers, but not in a significant way. So, summing up, what we're concluding from this is the effect of aspect on co-reference expectations previously found and replicated among L1 users does not generalize to L2 users, neither offline nor online, even among proficient L2 users, and even when aspect affects co-reference in the L1. This is from study 1. So, yes, this is consistent with the rate hypothesis, but again, we have a null effect of proficiency, and I was getting really worried, what's my lab doing wrong that we're keep getting these null effects of proficiency? But then I realized that everybody else is basically finding this as well. Several of these studies specifically set out to see to what extent proficiency modulates predictive processing, and all of them report null effects. Most notably, the HOP study and the Mitsugi study, they found effects of proficiency on incremental integration. So they were definitely capturing relevant variability, but that same variability did not impact predictive processing. So I just want to drive this point home because I keep hearing it, oh yeah, and proficiency will modulate predictive processing. Our intuition is that it might, but the results, the evidence seems to show us otherwise. Very few studies have found any modulation by proficiency, and I believe there are compounds in those studies. So this had me also worried about our rate hypothesis, because really the prediction is that if this is a bandwidth problem, then it should get better with increasing proficiency. And that made me think about a little bit more deeply about prediction and the costs and benefits of prediction. Prediction, everybody likes it. It's cool. We want people to engage. We want learners to engage in prediction, but really there's costs associated with it. So far, we focused on the benefits. If you predict, you have like a leg up. You're a little bit ahead of everybody else. It'll be easier to process the input when you get it because you've already anticipated it. That's great. But what if your prediction's wrong? Then it's actually more costly because you've got to undo, unstitch what you have done, regroup, reanalyze, and then process the incoming input. So it's creating more work for you. What this means is that engaging in prediction is really only worth it if you're pretty sure that you're going to be right most of the time. And that, I think, reminded me of a very insightful quote from Carol Federmeyer. And this has nothing to do with second language acquisition. This was in the context of predictive processing in elderly adults. She wrote, "Predictive processing may not be the best or even a viable strategy for all individuals at all phases of the lifespan and or in all processing situations." And I think this is really worth thinking about in a context of non-native processing. It also aligns with Kuperberg and Jaeger's thinking of prediction as a utility function. And the quote here is a mouthful, but let me read it for you, and then we can try and unpack it. I quote, "We suggest that the degree and level of predictive pre-activation might be a function of its expected utility, which in turn may depend on comprehenders' goals and their estimates of the relative reliability of their prior knowledge and the bottom-up input." So it really is about, is it worth it putting my eggs in that basket? Am I sure enough that it's going to be right most of the time? Otherwise, the expected utility is not greater than if you just held off and wait for the signal in the input. What it also means is that what is best for L1 users may not be best for L2 users, because depending on your learning history and the amount of exposure you've had to a language, the amount that the chance you've had to automatize your processing, your chances of being wrong might just be too great for prediction to give you any benefits. So it might actually be the smart thing not to engage in prediction. It might be more efficient not to predict, depending on the state of your linguistic knowledge. So we've tried to bring up the possibility that differences between L1 and L2 users in engagement in predictive processing may not or not only be a matter of reduced ability to predict, but of differential utility of prediction to successful processing outcomes. And I just haven't come up with a new acronym yet that gets rid of ability and brings in utility. If anybody can think of a good one, let me know. But I think ways that we can pursue this further in future work, and I'm engaged in some collaborative work trying to do that, is to explore the conditions that make prediction useful in language processing more generally for all learners, and then understand how that might apply specifically to second language learners. And most importantly, if there's one take-home message you take home from this class today, is to do not assume that what is most efficient in L1 processing is necessarily most efficient in L2 processing. This is a sentence I made up, but I feel I've read it so much as a reader, as an editor, and I'm probably guilty of having written sentences like this in the past. The goal of this study is to test whether L2 learners can achieve native-like processing efficiency. I think this may just be the wrong way to think about processing efficiency. So I hope never to read sentences like this again in manuscripts in the future. And I'm going to leave it at this. I've diverged a little bit from the visual paradigm, but I'm happy to take questions about any aspects of what I've been talking about if we have time.